We're going to look at a few more trig integrals. Here we have integral tan x dx. We're going to rewrite tangent x as sine x over cos x. So integral tan x dx, that's equal to integral sine x divided by cos x dx. That's because tangent x is equal to sine x over cos x. We're going to apply U substitution. We're going to let u be equal to the denominator cosine x. Its derivative du will be equal to minus sine x dx. Divide both sides by minus 1, we get minus du is equal to sine x dx. So what we have is integral 1 over cos x. We'll rewrite the integrand to make the substitution a bit easier to see. Times sine x dx. Now 1 over cos x, this part is going to be 1 over u. And sine x dx, this part is minus du. So what we have is integral 1 over u times minus du. I'll pull the minus 1 outside. So we get minus log of u plus c, because integral of 1 over u is log of u. And that's equal to, put u back in, we get minus log of cos x in absolute value plus c. Now let's apply some properties of logs to rewrite this in an easier way. So we have minus log of cos x plus c. Now because of the property of logs, this property, we can write the exponent, we can write the negative 1 up in the exponent. So that's going to give us ln of absolute value of cos x to the power of minus 1 plus c. But that's the same as ln of 1 over absolute value of cos x, which is ln of secant x plus c. So what we have shown is the integral tangent x dx is equal to ln natural log of absolute value of secant x plus c. We're going to need this result when we do the next example. So here we have integral tan cubed x dx. Whenever you see an odd power, it's a good bet you're going to reduce the odd power by 1. So that usually solves the integral, or at least helps us solve the integral. Tan squared x, tan x dx. Now let's apply trig identity. Tan squared x is equal to sec squared x minus 1 times tan x dx. Let's multiply the tan x through, and we get integral tan x secant squared x minus tan x dx. Let's split up the integrals and integrate piece by piece. So we have integral tan x secant squared x dx minus integral tan x dx. Now to solve the first integral, we can just do a u substitution. We'll let u be equal to tangent x. Its derivative du will give us secant squared x dx. So the first integral will be integral of u du, and reversing the power rule, we get u squared divided by 2 plus c. That's equal to tan squared x divided by 2 plus c. So let's label the integrand to make that a bit more clear. So tan x, this part is u, and sec squared x dx, this part is du. And when you integrate u du, you'll get u squared over 2 and put u back in. Now, the second integral, we've done that before. That was done in the first example. And that was log of secant x plus c. So now it's just a matter of putting them together. So what we have is integral tan x secant squared x dx minus integral tan x. And the first integral came out to, by doing u substitution, the first integral is tan squared x over 2. And the second integral was solved in the first example. Integral of tan x is log of absolute value of sec x. So now we just put them together. So that's tan squared x divided by 2 minus log of sec x plus c. So when you're doing questions, it's a good idea to just memorize that integral tan x dx is equal to ln of absolute value of secant x plus c. All right, let's look at another example. This is a kind of a theory type question. We have proved that the integral of secant x is equal to ln of absolute value of sec x plus tan x in absolute value plus c. Now this is really hard to do unless you have a hint to solve this question. And the hint is to multiply the secant x, the integrand, by sec x plus tan x divided by sec x plus tan x. And we're just multiplying by 1, so we're not changing anything. But by doing so, it basically solves the integral. So what we have is integral secant x times sec x plus tan x divided by sec x plus tan x dx. So let's multiply it through and we get integral secant squared x plus tan x sec x divided by sec x plus tan x dx. Now, if we let u be equal to sec x plus tan x, the denominator, so let u be equal to sec x plus tan x, its derivative will give us, what is the derivative of secant x? The derivative of secant x is sec x tan x. So that gives us sec x tan x plus, what is the derivative of tangent x? Derivative of tangent x is secant squared x. Secant squared x, put this in brackets, dx. So what we have is integral. Let's rewrite the integrand to make the substitution easier to follow. We have 1 over sec x plus tan x times the numerator secant squared x plus tan x sec x dx. All right, you will see clearly that this part here is going to be 1 over u. Now this part is a bit harder to see because the addition is in the reverse order. So you'll see that here we have sec x tan x plus secant squared x, and here we have secant squared x plus tan x sec x. But the order of addition doesn't make a difference. So this is just going to be du. All right, so now we have what we have is integral 1 over sec x plus tan x times secant squared x plus sec x tan x dx. We did a u substitution. We let u be equal to sec x plus tan x, and its derivative gives us sec x tan x plus secant squared x. So we have integral 1 over u du. And again, this part here is 1 over u, and this part is du. All right, so what we have is integral 1 over u du. And what is antiderivative of 1 over u? That's ln of absolute value of u plus c. That's equal to ln of sec x plus tan x in absolute value plus c. So what we have shown is that the integral of secant x is ln of sec x plus tan x plus c. So it's good to memorize this as well, otherwise you'd have to prove that. All right, thanks.